Hey, hi Raghavendra. Good morning.
Hi.
Hey, Raghavendra, I think you joined today as the first session, right?
Yes.
Okay, got it. And like, I mean, just if you can share like about you, like what you do, and any prior experience in any of the programming or databases, and your expectation from the course. If you can share a couple of minutes.
I'm basically working in claim side
Okay.
as a subject matter expert,
Mm-hmm.
and I have idea about Tableau and Power BI.
Okay.
I want to know like SQL, so that is the reason I was checking.
Okay, okay, no worries, no worries. Okay, you have experience in any other other than I think Tableau, Power BI, you
Yeah.
might have used some sort of SQL already, right? Part of your
Yes, sir.
yeah.
But I'm not proficient in
Mm.
Kubernetes.
Okay, got it. No worries, no worries. Okay. And anyone else in the call today? I see Lavanya, Mahesh, and Jagruti. Anyone you who did not join yesterday and or joining first time today, please let me know.
I have joined yesterday, Venkat.
Eh, Yeah, I remember.
Yeah.
Thanks, Jacob.
Yeah.
Okay, we'll wait for another minute as others giving next minute or so for others also join, and then we'll start with today's session. And meanwhile, what we'll do, we'll just have a small recap of what we discussed yesterday, right? So, and Jagruti, Lavanya, Mahesh, like you guys have joined yesterday. Maybe if you can take a minute to share like what you understood in yesterday's session, and uh, maybe just a minute or a word or two of what you understood, so that anything for correction or anything in a different perspective to look in, I can share the details on top of it. Yeah, Lavanya, please go ahead. I see your hand raised.
Hi, Venkat. I
Hey,
have a small doubt. Types of
sure.
database, cloud database, I didn't get.
Mhm. Sure, I will share more details.
Okay.
So typically, most of these databases, right, whatever
Mm.
we are seeing, these are typically what you call developed as an on-premise databases. Okay, so these cloud databases, when I meant these cloud databases, something let's say for Amazon
Okay.
Amazon
Yeah.
RDS, Relation Database Service, or the Microsoft Azure SQL database, and the cloud Google Cloud SQL database also. These are also
Okay.
works similar to the RDBMS. The concepts,
Mm.
principles are same, but these are developed native to the cloud, not like initially it was developed and on-premise, later converted to cloud. Let's say for Oracle example, right? Oracle for about like 30 years, it was an on-premise database, right? So we install that on a server, and there are few what you call in terms of the way it works out and the way it is developed, it is quite different. Now later, with I think from after 12C onwards, slowly small changes are being made, and now with I think almost from 19 and 19 onwards, and mostly from 23A onwards, Oracle has also converted into full term as a cloud native database.
Okay. Thank you.
So the principles might be same, just that the way it is developed, the way it is designed is different. That's the only difference.
Okay. Okay.
And any other questions? Anyone? So
Thank you.
no worries, no worries. Okay, so just to have a recap, I mean, in case anyone missed any of the uh, got disconnected in between or missed some of the content, I'll just have a recap for about 5-10 minutes, and then we'll start with today's topics on it. Okay, so I think Raghavendra, you're joining today for the first time, right? So this we call it from Logic Labs Technologies. This is batch 354 for Oracle SQL and PL SQL, and this is starting from 9th of September, which is yesterday. And the first 3 days are the demo or introduction sessions, and later on we will start with the actual hands-on sessions, access to the databases, and how to access and all those details, and how to connect. I would share it from the day 4 onwards with the registered participants. And day 3 we would it is a free session for everyone to join, where we would check about like how the SQL works out. We'll have a small walkthrough of connecting and everything, and I'll show you the table creation, queries, and all the joins which we are going to learn as part of day 3. But the recording of day 3 session would be available only for the registered participants. Okay. So day 1 and day 2, it's open to everyone. It's introduction session. Day 3, we'll have the introduction to SQL, and which is available to registered participants, and all the access details, how to connect, how to install, and all the details. We would start with that activity, and we would cover a in the first session, I would walk you through the use case, what we are going to work with. When I say use case, it's not like a project, but the queries, how we are going to write it, okay, how we are going to understand it, utilize the concepts, is driven from an scenario or a use case perspective. So we would take an e-commerce sort of platform, where we would understand how different entities are lying up in the e-commerce, and how the data is fetched, as in, let's say if we developed everything on Oracle PL/SQL, and how we would create the APIs for it, the database APIs, how it can be accessed from the API, and how tables joins between them will be present and all. So we'll try to mimic one of the e-commerce scenario, and we will try to design the backend APIs which are required for it. Okay, and for backend APIs, as we are talking in the Oracle SQL and PL SQL perspective, we are going to develop in the Oracle SQL and PL SQL. But same thing, depending on the type of database or backend system you use it, there might be different tech stack which you use. Maybe you might create an APIs using Java layer, or you might create using the Python layer on top of it, or maybe with with the MySQL and other things. You have a different approach for it. So we would have the same scenarios and the use cases were from the Oracle SQL and PL SQL perspective on it. And this is a 30-day course, starts from 9th of September. That's from 8 a.m. to 9 a.m. on weekdays. And on every Friday, we would discuss through assignments, which I would give you on Friday's session. And you can spend some time on the weekend or Friday after your day works, in the evening or Saturday or Sunday, spend some time, try to complete the assignments, get the hands on, and on Monday we would walk you through on the solution. We would discuss how you have approach to the solution, what problems you have faced it, you need some help and all to understand it or to develop it. On Monday session, we will spend some time to clarify those things. So that way you have uh, as a small assignment, same time on a day-to-day work, please try to spend an hour, not too much for it, because it's a 30 days. We are trying to discuss small things every day. So you try to learn or have the hands-on a daily work, so that you have enough hands-on, enough and confidence as you learn through the topics. Okay, so as I mentioned, The first three are free to attend, and from fourth day will be participants only. And day three recording will be shared to the registered participants. And everyday recordings or daily notes, whatever we walk you through, will be available on the LMS portal. We call it Graphy. And for the registered participants, you will have access to the Graphy portal as well. And everyday recording, whatever we go through, and the daily notes and additional reference materials. I do provide some reference materials on architecture or best practices, some of the best practices which we follow, any PDF documents or ebook sort of thing. I would share them across to you, which you can access on the LMS portal as well. Okay. In case you have any problem, any question, any query whatsoever, please feel free to reach out to the support team over the email or the contact number which is provided. And the available times from the support team are from 9 a.m. to 7 p.m. on Monday to Saturday. Okay. And technically, in terms of understanding concepts, feel free to use during the call, raise your hand, or you can use the mic or chat window, whichever you feel comfortable, and you can bring that point. We're happy to help you out on it. Okay. And in case you haven't gone through the portal or the details, so the Logic Labs uh, give this link once again for the upcoming batches. So you can see through all the upcoming batches and the course content, what we are going to cover through, or the WhatsApp community link to get the daily updates. You have everything here, and even from the registration link as well. For the course content, I'll walk you through once again. So we would start with the introduction sessions for both database management system, DBMS, and then we'll have basics of SQL, creating tables, selecting the data from the tables and everything. And we would work part of the SQLs. We will have all the group by, having order by clauses, subqueries, joins. We will learn about all those concepts, and later we will convert these queries and all to views as one form of structure, and the other form of structure we will learn about the materialized views as well, both the topics. And once that is done, we will move on to the PLSQL. We would learn the PLSQL structure, like what are the structure of it, syntaxes of the PLSQL, what are the different blocks or execution parts of PLSQL, and we will learn about the conditional statements, loop statements, whichever are required on our coding basis. We would learn about all those things, and then we will club these SQL parts, the insert statements, SQL statements, everything into the PLSQL components, where we will understand dynamically how to get the data and everything. So once the PLSQL concepts are clear, we would step into the named PLSQLs, where we would understand about procedures, functions, packages, and everything. And part of it, how to convert from the anonymous PLSQL to a named PLSQL, and what situations do we use it, how we use it, in what ways it's going to help us, and all the details. So eventually there are few more PLSQL components. We'll cover about all those things with bulk collections and bulk operations as well. And at the end, we would walk you through, for the last 2 days or so, we will walk you through on the database architecture and a glimpse of the advanced new features which are available, and some of the DBA concepts. Which DBA concepts, not as a DBA per se, but as a developer, you should also be aware some of those concepts of it, which would eventually help you to be self-sustained, and in terms of identifying or tracking some of the problem whatsoever, understanding some of those concepts will help you out in a day-to-day life. So we would walk you through in all these topics for it. Okay. And I think we discussed about these topics in yesterday's session as well, but in case people who have joined yesterday's session did not have any question, probably if you have any question today, or maybe the new members, if you have any question today in terms of the course content or topic, please do let me know. We'll try to clarify it so that you get enough confidence and before you actually do the registration as well, so that there won't be any dilemma, right? So whatever we are going to cover, we would cover on a daily basis. Okay, so if you have any question, dilemma, whatsoever, please do let me know. Okay, and in case you want to go through this offline, please feel free to access through the link which I shared over the chat window, and you can what do you call, go through the content and everything as well before you do it. Okay, yeah, always raise your hand in case any question or any doubt. They're the same topics. Okay. Uh, I'll pause in a minute here. Please let me know in case you have any question, doubt, or clarification. Okay. Yeah. In yesterday's topic, we had the baseline or introduction to databases and why a database would be required for you. Okay. And how it improves your process side of it, how streamlining or bringing some discipline in your business and the process side, right? So that's one way which we discussed, and we discussed about advantages and future tracking purpose or data analysis purpose which are required for it. Everything we talk about in terms of data, because it provides you one perception in terms of what's happening in the real time, because something which we can capture, something which we cannot capture, something whatever we captured, that should replicate as what has happened in all the events and everything what has gone through the data, whatever the journey of a person, right? So that's how we try to replicate the our databases as well to simulate our day-to-day real life as well. Okay, how maybe let's say a customer coming into a bank, okay, opening an account, maybe putting an application form, opening an account, okay, and opening what you call, doing some transactions over these accounts, maybe withdrawals, debates, or check transfers, whatever so it is, right? And the different ways he can access, maybe through an web portal login, or maybe through an ATM, or maybe like on the customer through the bank customer service. There are different ways he can interact with, right? So that lot of things which happened with conversations with relationship manager, conversations with in terms of employees within the bank, how the employees work within the bank. They're like huge uh, uh, huge scenario, right? So each of the person, a customer has a different persona to it, employee has a different persona to it, the relationship manager or the interaction between relationship manager and the customer has a different persona to it. So everything need to be interlinked in terms of an application. So we need to create our database, tables, or models, whatever it is, which tries to fit in to the real life journey of that entity, be it a customer, be it an employee, be it whatever, whoever is a person involved in overall bank operations, right? So all those people need to be replicated in one or the other form of database where we can capture all the activities what he is performing. That's where your audit or history comes in picture, right? So that's where we discussed, depending on the type of system it is, type of realistic scenario it is, you might decide the different types of databases, right? Let's say you have a weather report. Okay, so weather report you need to track every minute by minute or a second by second. So in order to understand, predict lot of other things, right? So you cannot do it on a day-to-day basis, right? And even in a single what you call uh, single system sort of thing or a relational database sort of thing would not suffice to it. So you need a time frame based or time slices based database where you can identify, track the data on each time or each second which is happening out. Eventually it will drill down to on a weekly basis, monthly basis, or a yearly basis, whatever is happening. So you need to capture a lot of things at timely basis. Same thing, be it let's say your GPS location. You want to track a delivery person where it is present. You want to track your order something. So you need to have a real time integration with the person location as well. Okay, so every minute what location is present, okay, how what direction is traveling to, you need to capture all those details. So that is again a time size location. Okay, it's a multi-dimensional again, which need to identify the GPS location coordinates as well as the time slots as well, right? So depending on type of scenarios, you would decide what type of database you would work with, right? So all the systems, right? The fundamentals or what called the method, the way the data is stored might be different, underlying matching with the scenarios. But the methodology, whatever they follow, the principles, what the database should honor are the same. Only the type of the way the data is stored, the way data is represented, the way data is modeled might be different. But how you access it and how the principles of data, whether the data needs to be secured, data need to be easily retrievable, and how the data should be backed or recovered, the principles are the same. So that's where we come into the software side of it or the management side of it, what we call in terms of databases as database management systems. So when we talk about Oracle or MySQL or Azure or whatsoever, to us it is a database management system. We don't deal with the direct raw data underlying, right? We use raw data as a way of communication, format of communication to it, along with the language whatever we provide. So this database management system should provide you the framework of modeling, how you can design your tables, how you can design your data, what format data need to be present, what are the relations between data. The data modeling need to be done for it. And comes to data storage, how data is stored internally, right? Similarly, if you have an as we discussed, right, we have an Microsoft Word. Okay, it's an application which Microsoft has provided. You type in some raw data, right? It saves a file as a Word document or a dot doc or a dot docx. It saves in the format. When I open that file in a notepad, I don't understand anything because I see complete junk characters, some hidden characters, some raw characters, which I don't understand anything. But if I open the same thing on an application, Windows, the Word application, I can see the data in a proper structured, like the paragraph, headings, table content, complete structure, images, everything is completely given for us. So the way it is stored, it might be something on a commercial side of the application, or it's completely on the application uh, identity side of it, but it might be different in the way you what you call access it, right? So I just access it from a Word application. It's very simple and UI base of it. There's a That's one language which the Windows understand. Maybe you want to highlight some word, you select some text, you bold it, or highlight some word, convert the fonts and all, right? But internally, the way it stores the data, it's up to Microsoft way of writing the data or storing the data. So that's where the data storage comes in picture. Similarly, for Oracle database, you might have tables. What file I need to store, I can decide. Where I need to store, which drive I need to store, I can decide. but internally how it is managing, how optimally it is managing saving the space for me, it is from the Oracle side of it. That's where the database management comes in picture for you, which can handle the memory management and space management as well. And the data retrieval, you need an access language for you, right? You need an access language for you where you can talk with the system, just like how we are using Word, right? You have some different UI typing and everything, right? Similarly, for Oracle, it has a different, for pure databases for storage purpose, it has a different language, right? So here we use the SQL, what we call as structured query language. So it has a proper structure. The syntax is what we use. It is close to our English language. So that's why it's easy to learn. And most of the databases, whatever so the data modeling they use, whatever so the way of multiple ways of accessing they have it, all the databases will have one unified um, uh, way of access is using SQL. The some of the functions which I use, some of the representations which I use might be only to that database which we use. Maybe the SQL might have few couple of functions a different way. Maybe Hive or Presto might have different functions or which is additionally available, depending on the way that system is designed. But in general, all these databases have SQL as a common unified language to access the data. There might be few additional way of accessing as well, using maybe an Python based or an CSV based model sort of thing, or the different UIs which are available for it. There might be different way of talking to it, which is additionally which the database provides us. And the data integrity, right? So whatever data we provided, we talked about, you customer is going to use your database only if the data is consistent, right? Data what is present today, if I query from mobile device, let's say if it's a banking application on my mobile device, it shows as $100 available in my bank account. From an desktop application, if it is showing it as like let's say $900 available in the bank account, there is no consistency, there is no integrity for it, there is no accuracy for it. I can eventually, the trust which customer would have on my application or my bank will be lost. Eventually, it degrades my customer base altogether. So I need the data whatever you access. At, at a certain point of time, you have some data. It should show the same data in whatever way it is. So the data access you do from the database, it has to maintain that accuracy. It has to maintain that integrity as well. So that's where we talk about a lot of constraint rules and validation rules as well to maintain the integrity and to avoid the junk data in your database. So more the junk data, less the confidence, less the trust on your application. Same thing comes with the data security as well. So you store your data, but if the same data, your personal information, if it is available publicly, right, in any of the form, maybe on your web portal, if there is a security breach, someone can access it. Maybe underlying data storage you have it, there might be a security breach, someone can access the direct data storage. Let's forget about the data access layer. Let's talk about the data storage. If the data hard disk where the data is stored itself is not secured, so you need to understand the journey starting from where the data is stored, how the data is accessed, how the data is transmitted, how the data is viewed. You need to go through all the sections where the data is traveling through, and all the systems in your eco space, right? The digital eco space need to be secured, not just on the database side. Database eventually is a priority for us because that's where the raw data sits in, and you need to have the encrypted data or hashed data so that even if someone uh, 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 gets hold of your hard disk as well, right? data is completely secured for you. It's hashed or encrypted. He cannot access the data. So you need to think about multiple approaches where, because data in hard disk should be secured, data in travel over the internet, it should be secured, or else I can hack the networks, whatever you have it, I can steal the data as well. So all the layers need to be secured for you. That's where you say that's a secured application, and eventually the trust on the organization, trust on your systems will increase. And same thing with the backup and recovery, right? So backup and recovery eventually are the which comes from the risk management perspective. So you might have all these things: data modeling, storage, retrieval, integrity, data security, everything taken care. You need to have the access management as well. What you call the backup and recovery aspects as well. What happens if something goes wrong in your data center? Right. So everything is secured that people can rely on it, but it's of no use for me if data whatever I stored in your uh, uh, database today, if tomorrow database is not available, it's of no use again. Even if I say 1,000 times data is secure, data is integrated, everything done, but I cannot access the data. So I need to have a backup plan. So it can be everyday backup, it can be every hour backup, and the recovery plan. Let's say if I have an everyday backup, right? So let's say yesterday night, uh, uh, 6 p.m. I've taken my backup of the database. That's well and good. Now today, mid of the day, let's say 12 p.m. sort of thing, the system crashed, and I need a backup mechanism so that my application will be running fast. Now, if I use the backup, right? So backup, it is of last 6 p.m. yesterday, which means I'm going to lose about like 18 hours of data still, because it system gone down today at 12 p.m. for example. So I do have the risk management, the recovery cycle for it. Like, how can I recover the data? Let's say data whatever is available to 6 p.m. That's the first step which I can bring it down and say to all my customers saying that there is some issue. Data you see it is still 6 p.m. So any transactions you have done after 6 p.m. Probably this might appear back on your accounts whatsoever, or data would be corrected or refreshed maybe another hour or another 6 hours. So, and in this time period you need to use this backed up device and identify the delta whatever has happened and then recover the data. It might be different permutations and combinations, right? So that's where the backup and recovery comes in picture, where your database management system should have this functionality inbuilt for backing up your data as well as recovering it in case something goes wrong as from the risk management perspective. So all these are the components of your databases. So part of the session for the Oracle SQL and PLSQL, we would cover about data modeling, creating the tables, relationships, everything. We would talk about data storage for creating tables, inserting data, and selecting the data and everything. And the language, whatever we use SQL and PL/SQL in both ways. And we would discuss about integrity, how it is maintained, accuracy, how it is maintained, and data security, how in the Oracle side, data security can be maintained. Access to these tables can be restricted. How Oracle handles those things. And backup and recovery, we are not going to go in details about backup and recovery to it because it's more from the DBA perspective. But from the developer perspective, as your day-to-day development activities, we do the backup and recovery to some extent. Okay, how we can do that and all, I would show some of those examples also. And so as we discussed different components of the uh, database management system, right? So you can map each of those components, right? So each of those necessary building blocks or the primary base blocks of your DBMS, you can map those into the components of database. So what I would require, I need a storage to store the data. I need a query language, a language of communication between database and the user, and I need a query processor which understands what query the user has given me, understands that query, converts that into executable path of it. Okay, it needs to convert internally to executable path of it, right? So you need a processor for it, and you need an optimization engine which tells like the user has requested like so and so data. What is the quickest path for me to get the data? Right? I cannot go always from first to last for anything which I need to bring. I had to find an optimization method to fetch the data faster and to get the data faster. And we have something called as metadata catalog, where we provide all the meta information, all tables you created. This is like super information for you, right? How the system is working out, how tables are created, how much space I'm using it, all those meta information, okay, which database management creates internally based on your activities on the database. So just like an audit purpose from the database management side as well. And all the activities you do, you need to have a log for it, like what time any activity has happened. So you need to maintain a log for those details, because as the data is crucial for you, there are many audit and compliance activities as well on top of your databases. So to make sure your data where you are storing is complete, safe, and secure, no malfunctions, no unnecessary changes in the customer data whatsoever is happening without the right authority to do, unless without a right consent as well. So we cannot change the data as we cannot see the data as well. So accordingly, we will maintain a log manager to identify all those activities. And reporting and monitoring tools, eventually you would require to any system. I need to have a report, I need to have a dashboard, or I need to have a monitoring tool to identify, uh, to basically have an observability side of it from the database. And utilities, obviously, to do all those activities, right? Sometimes not individual statements or queries would work out. You need some sort of automations, you need to some sort of what tools to utilize of it. So that's where we talk about data utilities, where we would discuss about how, in what cases, what type of utilities would be required for. So these are the different components of databases, and we would discuss most of these things in our learning path as well. Okay, yeah, simple representation, because uh, whenever we talk about databases from now on, there are two views of it. One is the physical view of database, which is the actual storage which we do, and second, we have the virtual. Uh, this is the physical files which we have it, and depending on the type of data, you might have it as a relational database, a hierarchical database, or a flat files database, or the database objects. Depending on your type of database you use it, your structure of database might be different internally. Okay, that is taken care by the database management system. It manages how it is storing and everything. But that is the physical data for you, actual raw data which is stored in your hard drive. And we have, with the DBMS, we have all the applications which are created on top of it for access layer and everything. All the data which we come through it, access from the database, we call it as a virtual view of it, a logical view of it, not the physical view. Physical view, we wouldn't know. How it is storing? It is storing in a table format. It is storing in a simple raw text format with all the data together. We do not know. It's completely to the logic of database management system and the proprietary logic of database management system, how it is used internally, how it is stored. But for us, we use it via a virtual or a logical view representing the mode or means using the SQL language. So all these functionalities are part of the database management system for us, and we would walk you through when we come to the architecture as well. All these components, whatever we discussed, we would see through them as well. Sorry. Okay, and as we're talking about Oracle database is commonly referred as Oracle DBMS or Oracle database in simple terms. The latest tech stacks with the cloud database of Oracle, we call it as autonomous database. And some of these activities like backup, recovery, alert, monitoring, lot of things which used to take lot of efforts and generating lot of logs, reports, sort of thing. It is kind of simplified a little bit, okay, where you can access everything on the Oracle, uh, what do you call, on the Oracle cloud itself, and alerts, all those things, maintaining of the table space, everything are kind of automated within the database. And for Oracle, we have like two different systems, not just for Oracle, any database, we have two different modes of it. One is the transaction processing, and the other is the warehousing. And some systems use a combination of these two. Combination of these two, this is the most uh, frequently chosen approach in an enterprise level. If it is depending on type of application we run it through, some systems might end up with only transaction processing. Some systems might be designed handling on data warehouse, and some databases might have capability of both the things as well. Because let's say banking application, right? Banking application again is divided into two different sets of application. One is an OLTP application where you have lot of processing power because the transactions need to go faster. User cannot wait minutes of time to complete your transaction. If you use a mobile app or an e-commerce application, it takes fraction of seconds for you to just add something to cart, do the checkout, do the payment, everything. Probably less than a minute you complete your whole process, right? So we use transaction processing for it, where the data is cached, whatever you're accessing, data is indexed properly, data is managed properly, and it is made accessible quite fast. And data warehouse, it's going to contain the warehouse, right? So name itself says it's a warehouse. It's a huge data. You have like tons and tons of terabytes and bigger gigabytes and petabytes of data available in your data warehouse. Now you do this data, historical data, maybe like years long. Some application might have like 1 year, 2 years. Some application might have like 10 years, 20 years of data also, depending on the requirement of each application. We analyze, access lot of this data, do lot of analysis, be it on a day-to-day basis or be it on an yearly basis. Accordingly, we do lot of data access for it. So data access, it does not require you to happen in fraction of seconds, but it requires you to handle huge data and huge processing power, huge memory power which is required. So the the way the system is configured for data warehouse is different in terms of the memory management or space management and everything. And there are few applications like a mid-level component. So uh, I cannot maintain too much infrastructure, one for transaction processing and other for data warehouse, because mine is like a small application. So I might have like few hundreds or few thousands of transactions every day. So in that case, I can have a mix of database. I can choose an optimized configuration for my database, which would work as both the OLTP as well as data warehouse. And from the Oracle side, uh, we can use both OLTP as data warehouse depending on configuration you do for your and the first official release, like I mean, it's available for anyone if you go through the Oracle website also. The first official release of Oracle, it's happened somewhere 1979, way long back. And the latest release, which is available 23 AI, and probably I think we might have something new coming up soon as well, and which has a lot of these automated approaches which I was talking through, right? A lot of these AI features and all. We will have a glance through like what features and all at the end of the course as well. So once we cover the main topics, what we require. And coming on to relation database, so we talked about multiple databases, everything, right? In terms of relation database. So when I talk about relation database as a common thing, in simple, you can treat it as a table-based approach. You open your diary, your school diary, college diary, or your maybe the college entry form or a student entry form, whatever it is, or the attendance history in your school, maybe in your work, in your office, you have some data which is captured from the users, maybe entry form, whatsoever, right? Whatever application you use, maybe an Excel based application, whatever it is. 99% of the view which we get when we see the data is in a matrix format or a table format, where we have multiple columns in it, and we have multiple rows in it. So rows represent nothing but the individual record, and columns represent nothing but different properties or attributes we are capturing. So that's where the relation database comes in picture. So each record has some or the other properties we are capturing it, and similarly there might be multiple tables within my database. I can have a relation as a parent-child relation to it, or a primary key or a foreign key relation to it. This is a relationship between multiple tables which are involved, which would replicate my business scenario. So in these sort of applications where we have a relationship based and we store the data in the table format, which is commonly used, which mentioned what we call as relational database. And all the things whatever we discussed are the same, right? So the concepts, the basic fundamentals of database remains the same. And for database, what we in general called as database and in general called as database management system. Now something we are cutting it down, narrowing it down to the type of database as relation database, and the database management system we call as relation database management system, or RDBMS. So all the SQL based indexes or this format of this methodology which is used, we call it as an RDBMS mode of it. And the principles whatever we learned from the database management system are the same across everything. Just the way of representation it, the terminology might different, but the essence is the same, the principles are the same at the database level. So one, I have multi-user access, right? So it's not that one user who is going to access your data. I need to have multiple users accessing it in concurrence, in parallel, multiple places. So it should be multi-user accessible database for it. If it's one user accessing it, I can have a simple file-based system. I don't need an relational database for it, right? So a multi-user should be accessing it. That's where the collaboration comes in picture, and data durability, right? So it should not say that okay, I have only 10 MB space, okay, I cannot extend the space more, you cannot store more data, or the columns you have I have only numbers columns, let's say in my database, I cannot store any characters. I cannot store any names. I cannot store any dates, or I cannot store any timestamps. It is of no use for me. The database should be durable. It should be sufficient for me to extend the space if required. I can add additional space. At the same time, the columns, whatever you use, tables, whatever I created, there shouldn't be any restriction in terms of number of type of columns I use, number of rows I have it, amount of space I capture. There shouldn't be restriction. I can keep a restriction for the safety purpose, saying that today I have a 10 MB space. 10 MB space. If 10 MB space is filled up, I can allocate more space to it. But it should not say that this is the end, you cannot do it. No one will purchase your application. That's where we talk about multiple physical files. We add an additional hard disk, additional ROM, additional space to your systems, and that's where we extend the data as well. So that's what happens typically in your what you call in the on-premise systems, right? So you have a physical limitation, right? So at that point of time, it's limited to this. If you want to extend more, you need to add additional disk space and all the details. So that's where the cloud systems comes up with these automated mechanism where these space constraints are all like very minimal to you. And data consistency. So we discussed about data consistency earlier. The information what you see, it has to be consistent. So wherever you use, what time you use, doesn't really matter. It has to be consistent. It has to replicate the real value, the truth of the data. It has to be consistent. And data flexibility, I think we covered it. In terms of the columns I have it, maybe I can have a column of, let's say, 10 characters. It has to be flexible. I can add data of 100 characters as well. I can extend the data. It should be durable. It should be flexible as well. And hierarchically, the data whatever I maintain, it has to be hierarchically relationship. That's where the concept of RDBMS comes from. It's a relation based database. And asset properties, we call it as atomicity controlled and asset properties, where at the granular level I should be able to lock the data, modify the data, and update the data as well. Let's say if you see something like an SharePoint or Google Sheets or Google Document and all, right, multiple users can modify the data at the same time, can access the file at the same time, can work in collaboration. Okay, the person one might change something at row number one, person two might change something at row number three. System will not stop you. It only stops you to avoid the changes in the same column or the same row. And so that two people cannot modify the same line or same column data at the same time. It would say the data is locked for some other purpose. So that's where the ACID support comes in picture. Right? So I cannot decide if a person A is typing A, person B is typing B. I cannot decide what should be there. I need to have a safe mechanism. If person A is typing it, I would say it is locked for person A. You cannot type it now. Once the A is done, I can allow person B to type it. So I have to have some sort of mechanism to control it. There might be technically not possible, right? So I have to have a workaround. What is the process I can follow it? According, that's where the asset property or asset support comes in picture for us. Yeah, yeah, the same concepts, whatever I discussed earlier, and I will pause in a minute here. Please have a glance through. Let me know in case any of the section is not clear for you or it's not understandable. I'll explain that. But concept, whatever are covered in the previous slides. Okay. Any questions, any doubts, any clarifications? Might not be just this slide, maybe the previous topics what we covered. any of the thing which is not clear, please do let me know. Okay, cool. And as I said, in relation to database, everything we talk it in form of tables. Okay, and the columns, what we call, uh, I think there are multiple nomenclatures or words we use. Initially, we call this as attributes. Okay? Even now, some people call them as attributes only. Okay, there's nothing wrong here. Some people call it as columns also. Okay, or some people call it as properties as well. Because if I take it as one of the gadget or a material, I can say different properties. But technically, I've created them as columns in my table, and logically these are not these are technically columns, but logically these are nothing but attributes of a particular entry. So that's where different surnames or the different terminology which is being used. So on the whole, this what we call as table, and each records, we call it as record, we call it as row, we call it as tuple as well. Same way, these are called as columns, attributes, and properties also. Depending on the kind of system you use, some people might use different terminology as per their convenience of it, but it's all what it means. Okay, and these are individual rows in simple terms. And nothing but what we covered. Table nothing but set of records, set of rows, set of tuples, and tuple is nothing but one record or one row which is having multiple different properties of it. And the table name, whatever we call it, okay, this is nothing but what we call as schema also, table schema. That's the technical jargon which we use in any database or any place we go through. We call that as schema. And these columns, whatever we have it, are typically called as columns. And the unique column, whatever we have in our table, we call them as keys. And there are different words to it. Some we call it as unique key, some we call it as primary key, depending on minute differences how the definition is created for those. But in general, any unique value which helps you to identify a unique record in your table, we call them as a unique. Simple like a student ID, or your hall ticket number, or an employee ID, or an other ID. All these are unique. It cannot be duplicated, it cannot be replicated into multiple people. It identifies one record in your whole table. So that's what we call it as a key in simple terms. And data integrity, as I mentioned, for RD members, we have two options for it. One, the entity integration, a duplicate rows cannot be existing. It's a like unique key which I mentioned, right? The record should be unique within that entity. So let's say if I have employees, two employees cannot have same employee ID. They can have same date of birth, they can have same address, they can have same city or country, that's fine, but their employee ID which is uniquely identifies that person in my database, it cannot be different. Yeah. And domain integrity, right? So where we are restricting some data, let's say for example when I say domain integrity, right? So I might have customer status. Customer status can be new, active, inactive, or deleted. It cannot be anything else outside of these four. So if there is anything else outside of these four, which means the data which I'm storing for as per process, it should be only four, which have some other entry, a fifth entry, which is outside of process, which means it is violating my domain. the domain is breached. That's where we call as domain integrity. And referential integrity, where I can have a reference in the other table, which I was referring. It's a relational database. So I cannot, if I have an order, okay, order would have a link to the customer ID, right? So order is independent. Customer is independent to customer, but order is again dependent on customer. I cannot place a alien order in my system without having a valid customer ID reference. I should have it, or else I do not know which customer placed the order and all. I, if it's a guest customer, I should at least have some sort of ID which would which is not a registered customer, but at least a guest customer, right? I should know which customer does it belong to. That is where the referential integrity comes in picture for you. And the user defined integrity, where there can be some business rules, right? So let's say, for example, I have shipping date. Okay? I cannot ship a product before the order date. Correct. Because these are two independent columns which I have it, date column. But from the integrity perspective, I cannot ship a product before even ordering it. So if there is something which is happening like that, which means there is a violation. So I need to identify all those sort of things, maybe the order status, all those things which would define the integrity of my business application, what we call as user defined integrity as well. So we would discuss about all those things when we create our tables, data models, and similarly, uh, while using the triggers as well, we would discuss about a lot of these concepts, how to handle them. And for database normalization and the next topics of creating the tables, we would discuss this tomorrow. This where we would understand how to create the table, what normalization we need to use it, and these topics we would discuss it in the tomorrow's session. So today we will pause in till the RDBMS and understanding of the table and the understanding of relations, different type of relations, different type of constraints we have discussed. And tomorrow we would discuss about the data modeling concepts, and we would discuss like what normalization, how to create table. I have a requirement, how to understand different columns within it, how to understand what granular level I need to create table, right? So there are multiple levels of granularity, and there are few principles associated to it, and we would discuss about these principles. And in general, most of at least 90 or 95% of the applications uh, end up only till the second enough or the third enough data only. They don't go too deep at the granular level, which eventually affects the system on a different sides of it. So as you go deep, eventually your burden in terms of processing might increase, right? Just like how you dive in your a pool or an ocean, right? So the more deep you go, the more the pressure you build it on your application. So you need to maintain some optimistic level to which you can handle that risk, you can handle that workload on your systems as well. So accordingly, we handle these normalization forms of it. Okay. So I'll pause in here for today, and tomorrow we would discuss about the normalization techniques, and we would understand on the SQL's part of it, what are different types of databases and all, and how to create tables, how to access data. Okay. Okay. I see a question in the chat from Mahesh. Okay. Uh, the difference between Oracle SQL and SQL. Okay, SQL, as said, that is an open language or a unified language, Mahesh. Okay, From Oracle SQL point of it, understanding with respect to Oracle database, like Oracle database might have few specific keyboards which is proprietary for Oracle, maybe few additional functionalities or functions which Oracle provides it, maybe something like an instinct, something like an date functions, maybe something the way it stores data internally, okay, maybe something the way the partitions are maintained. Some of these clauses might be different specific to that Oracle database, but that is only in this specific system based what you call functions or additional features which are available with it. But at a high level, the structure of SQL remains the same in all databases, just like select from table name, where condition, having group by or having clauses or order by clauses or having joins or subqueries. The structure of SQL remains the same, which is the base, which is common, a unified language to all databases. Some of the functions might change depending on the what you call the design of that system. Maybe Oracle might have few additional functions, out of box functions which are available for it, but that function may not be available in different database. Let's say if I have something like a user sort of thing, getting a runtime user accessing database, we can use select user from dual or some table. The same function is not available in, let's say, Hive or Presto, even though it's a SQL based or relational database. Only few specific system or those specific functions or specific keywords sort of thing are the difference, nothing else. I hope it answered your question. Okay. uh, any other question, anyone? Lavanya, I see your hand raised. You have any question?
Sorry.
Okay, no
No,
worries.
no, no.
No
No.
worries. Okay. If no other questions, probably we will wrap the session here for today, and we will meet tomorrow, same time. We'll continue on the normalization and we'll continue on the table creation and selecting the data. Yeah, thanks a lot, guys. Have a nice day. Bye.